Hello there, Mr. Sutton back again with another conic section lesson. This time we'll be tackling parabolas. So we're going to find equations of parabolas, graph them, and for our real-life application, we're going to model the feed horn for a satellite dish. Let's dive right into a practical application. The parabolic shape of a satellite dish, like this one, focuses the signal waves that hit the dish, these waves, into the feed horn, which is located at the focus of the parabola. Now, you might be saying, first off, hey, that was pretty cool. Let's see it again. Okay, there we go. Second, what is this focus thing? I mean, parabolas, last time we saw them, we were talking about the vertex and axes of symmetry and stuff like that, but a focus, I didn't know a parabola had one of those. Stay tuned. Let's give parabolas a conic section definition. A parabola can be defined as all the points that are the same distance from a focus and a directrix. Now, focus we've seen before, that's a point that a shape is kind of bent around, but the directrix, that's just a dashed line that's not actually part of the shape. It's also not an asymptote. It just is a line that helps us define this parabola. Now, halfway between the focus and the directrix, we have a vertex, which we'll call h comma k, kind of like the center of the other shapes. It turns out this is halfway between the focus and the directrix, and the parabola goes through the vertex and is the same distance at every single point from the focus and the directrix. Now, the distance from the vertex to the focus or the directrix, we're going to call that p. That's how the letter works out in these equations. So that means that, at least for this up-down kind of parabola, the focus is going to be h comma k plus p. Whatever this p value is, you just add it to the y value. But if you want the directrix, you have to subtract p from the y value. And since this is a horizontal line, it's going to be y equals a number. Y equals whatever k minus p comes out to. So that's a major axis y kind of parabola. Here's the formula for one of those. We've got y minus k equals 1 over 4p, parentheses x minus h squared. Turns out you can have parabolas that also go left-right. So for one of those parabolas, the equation would look like this. Now, you might be thinking, okay, this is kind of equation overload, Mr. Sutton. What's going on here? But don't panic. Notice that these both have a 1 over 4p in them, and the only difference is that the x minus h that was inside the squared parentheses is now outside on this other side, where y minus k is now inside the squared parentheses. So they just switch places. Whichever the major axis is, that's going to be the non-squared letter. All right, so what does that look like? Well, here's our directrix. It's going to be a vertical line. Focus is going to be to the left or the right of this. And our parabola now, which is still going to be with a vertex of h comma k, is now going left or right, depending on which way it's opening. This time, for the focus, you're going to have h plus p comma k, and your directrix, which is a vertical line, is now going to be x equals. This will be h minus p over here. In a little bit, we're going to graph a parabola. Before we can do that, though, we need to know the vertex, focus, and directrix, which we're going to find from this equation. Let's start by finding the vertex. That's just going to be h comma k. So we've got, remember, h is always next to x, wherever x is. In this case, we've got an h value of negative 1. And then our k value is going to be 0. This is really y minus 0, the whole thing squared. So negative 1 comma 0 is the vertex. To get the focus and directrix, we need to know the p value. We can figure that out by setting 1 over 4p equal to the coefficient of the squared term, which is 1 over 8 in this case. Because if you remember back to those parabola equations, back on this page here, both of those equations had 1 over 4p in front of the squared stuff. So, solving for p, we end up with 2. So now to find the focus, we have to add p to the correct coordinate of the vertex. And which coordinate's that? Well, it's going to be whatever your non-squared letter was up here. This tells you whether you have an up-down parabola or a left-right parabola. Since we have an x out here, that's going to be a horizontal parabola. So that means we have to add the 2 to the x value of the vertex, which is going to give us a focus of negative 1 plus 2 comma 0, or 1 comma 0. To find the directrix, we have to subtract p from that coordinate. And this is going to be the equation of a line, so we're going to have x equals -1 minus 2, or x equals -3. Now, how did I know it was x equals and not y equals? Well, it's a horizontal parabola going left-right, so that means that the directrix has to be a vertical line that the parabola is going away from. Another way to think about it is, what did you just add 2 to here? The x value. The x value of the vertex. So that's another tip-off that this is going to be x equals -3. At this point, we're going to graph a parabola. So we need to plot the focus, the vertex, and the directrix that we just found. So there's our vertex, focus, and directrix. Vertex was -1, 0. Focus was 1, 0. Directrix was x equals -3. And now we only actually have one more step here. We have to plot 2 more points that are the same distance from the focus and the directrix. Now this can be a little bit tricky if you've never done it before, but here's a little trick you can do. First off, how far is the focus from the directrix? Well, it's a distance of 4. Everything on this vertical line that your focus is on is going to be a distance of 4 from the directrix. Distance from the directrix is perpendicular distance. So you want to pick 2 more points that are also 4 units away from the directrix and 4 units from the focus. So how about we just count up 1, 2, 3, 4. There's 1 point. Let's count down 4. 1, 2, 3, 4. We're 4 units from the focus, 4 units from the directrix. Now we can just draw the parabola through those. Here's one for you to try on your own. Let's see how far you can get with this one. All right, for the vertex, you should have 0, 6. Note the 6 next to the y here. And then we have to figure out the p-value. So 1 over 4p equals -1 over 12. Cross multiplying, you have 4p equals -12, so p is going to be -3. In general, when you have a negative p, it means you've got a negative direction. If it's an up-down parabola like this one, a negative p means you're going to be opening down. If it were a left-right parabola, negative p means you'd be opening to the left. But as long as you just add or subtract this negative appropriately, you should end up with a parabola that faces the correct direction. So for the focus, we're going to be adding p to the vertex. Which coordinate on the vertex? Well, this is up-down, so we're going to do the y value of the vertex. So we're adding -3 to 6, so that's 6 minus 3 for the y value. So our focus then will be 0, 3. And then for the directrix, we're going to subtract p from that y value. So we're going to have y equals 6 minus -3, which is 6 plus 3, or 9. And let's graph all that out. So we have a vertex at 0, 6. Focus at 0, 3. That's right here. Directrix is y equals 9. That'll be a horizontal line up here. Next, let's pick 2 points that are the same distance from the focus and directrix. The focus is, let's see, 1, 2, 3, 4, 5, 6 units away from the directrix. So we have to go 6 to the left and 6 to the right in order to get 2 points that are the same distance from both. So 6 to the left, 6 to the right, and draw the parabola. And we're done. And notice that this is a negative direction, but again, if you add and subtract a negative like you're supposed to, it takes care of itself. For our last problem, we're going to find the equation of a parabola. Let's start by writing the correct formula for this. Since we have y values and a horizontal directrix, we're going to have to do the y minus k equals 1 over 4p x minus h squared 1. So now let's figure out, we need h, k, and p to plug everything in here. H, k, our vertex, that's going to be halfway between the focus and the directrix. So you have to find the vertex if it isn't already given. Halfway between -4 and 6, averaging those together, that's going to be a y value of 1. So there's our vertex, 0, 1. And now for the p-value, there's 2 ways you can find this. You can do the focus minus the vertex, and we have both of those now. Or you could do the vertex minus the directrix. It'll be the same value. So I'm just going to do a focus minus vertex. So that's going to be -4 minus 1, which is -5. plugging all that in now. We've got y minus 1, that was our k value. We have x minus 0, so that's just going to be x squared. And 1 over 4 times negative 5. So we have y minus 1 equals negative 1 over 20 x squared. That's all for parabolas. Till next time, this is Mr. Sutton signing off.